So I'm going to go up and just draw the thing. So I've got a sketch to see what the heck's going on. So basically doing your first guy. One of the things I'm noticing here is that this equation is in the form x equals a function of y.
Right.
So
but it's rotated across the x-axis, right? So it should be fine.
Well, I thought you said it was rotated across the axis y equals 1. What axis is this question rotating?
Yeah, so it says about y equals 1.
Okay, so not the x-axis, but parallel to it, if that's what you meant.
Yeah.
Right. Okay, so if I move this over a little bit so we can see it, the region that we're going to rotate is this region here, right? Where my mouse pointer is circulating around. And that green line is the axis of rotation. So I'm doing a quick sketch of this thing. And it looks something like this. Oh, that's a horrible sketch. Let's try that again. You should really take up art classes. Okay, I'm ready to switch over now. So we are going to rotate this fella and see what we get. So the region that's going to get rotated is this piece. The axis of rotation is the line y equals 1. And the axis of rotation is parallel to the x-axis. So we're going to be using the shell method. So if you do the volume with the shell method, it's going to be, since this is rotated parallel to the x-axis, doesn't that tell us that everything should be in terms of y? So we're going to be going from C to D, pi, a radius, a height, and a dy. So I need to know these two numbers, these limits of integration in terms of y. Well, this one's easy because it's on the line y equals 1, so I know this is 1. And this guy up here I should be able to find. And if I'd paid enough attention, I would have went to Desmos and wrote it down before I switched pages. Do you have that number handy?
Yeah, it's 5.
Okay, so there we go. So I will return now to our screen.
Professor, I think it's 2 pi.
Oh, yes, sorry. It is 2 pi. Yeah, bulk up. So I need a radius and I need a height. Well, when you do the shell method, your little rectangle guy that represents a typical slice is that guy, parallel to it. And I need to find the distance from here to here, which we're going to call the radius. And I need to find the distance from here to here, which I'm calling height. If you want to call it length, go ahead. It's the same thing. I need to know what it is. Right. So that point right at the end, right? That point right there. I'm going to call it coordinates xy.
Yeah.
So what that is telling me is that the distance from here is x, and the distance going up and down here, all the way to the bottom, is y. So let's see if I can put that together and get my two things. I have my radius and I have my height. That entire distance from here to here, this picture's getting really messy. If I put anything else in, even I won't be able to keep track of it all. But from there to there is y. From there to there is 1. The radius is the little piece that's left. So y take away 1. Are you happy about that distance that we're calling the radius? It's called y minus 1. I'm going to have to mute things.
Yeah, sorry.
Are we okay with that? Where that came from?
Yeah.
Okay, so all we're left now is height. Height is the distance from here to here. Height is the distance from this number, which was x
Oh, we
equals
can't
4.
see your screen.
Oh, okay, let's see what the heck I've done. See it now? Right. So this number here is 4. This number here is x. So that distance is x. That distance is 4. That distance is the thing we're calling height. And so what do I have? I have 4 take away x. Now the only problem with the height is that we don't want anything with x's. We need everything to be in y's. So what we need to do is we need to realize that x can be written as y minus 3 squared, because that x is on the curve. So this becomes 4 take away y minus 3 squared. And we now have the integral from 1 to 5, 2 pi, radius, and the height is a really messy looking, that guy. And I'm going through pens like nobody's business. So there's another.
Thank you. Yeah,
And then you do the usual after that, right?
Yeah. Yeah, I just had trouble with the height. I was like confused on why we would subtract it by 4. So.
Right, so you're going to have a something start and a something finished. And typically when you have that, you're going to take one thing and subtract the other. And in this case, the biggest is furthest to the right. So that was first. That's why there's a 4 there. And then you take away the other guy. If you'd switched these two around, you know, you'd have got the right answer numerically, but it would be negative.
Yeah,
So
I think, you said that yesterday.
You'd almost be in the right place. And it's a pretty easy thing to fix if that's the only thing that was wrong.
Okay, thank you.
Okay, you're welcome.
Professor, I had a question.
Yes, Mark.
So basically, the difference between like the disk method and the shell method is still like for shells, if it's like across the x-axis or a line parallel, it's the equations in terms of y. And then if it's across the y-axis or line parallel, it's in terms of x.
That's one of the major differences. The second, yeah.
Like so for disk, it's like they're the same basically.
Yes.
Okay.
That's true. So that's one of the major differences. The second major difference is that when you do the shell method, the formula is 2 pi radius height. But when you do the disk method, the formula is pi big radius squared take away small radius squared. So the formulas are quite significantly different as well. So there's two major differences. What ties them together is that they're both doing the same thing. They're both finding the volume of revolution, but they're tackling it from quite different perspectives. Right, where are we? I still have a few minutes. Stop sharing this for a while. And how are you today, Emma?
Doing good.
That's good. Like to hear that. Catherine, how's life?
A little tired today, but rather than that.
Yeah, getting old's not fun, right?
I know, it sucks.
Try to remember what that quote is. There's a couple of quotes. One goes something like, old age doesn't come alone, which I quite like.
Well, I see what my
You're
grandpa...
not old. Sorry, Catherine.
I said, I see what he meant when he used to joke with me about getting older.
Yeah. Yeah. I don't know. Hey, but my dad did that famous saying. He'd always say, you know, whenever you get really down, he says, well, She didn't always enjoy yourself because you're a long time dead.
Oh, yeah.
So I'd rather have creaky bones and tired days than not be here. What was the other one? Yes. Youth is wasted on the young. It's a good one. Yeah, you lot are smiling because you're young, but I was young one day as well, and I remember vaguely being young at least. And I would have had so much more fun knowing what I know now if I was young again. And hopefully I wouldn't have done so many stupid things. But that's life. Okay, where's the rest of the class? I noticed that she just turned up. Where is she? She's hiding. Jocelyn, can you hear me? Jocelyn, can you text me then? Because I'm not getting any communication from you.
What?
There you go.
Sorry, I'm looking for my remote.
Yeah. Yeah. I wonder if you're alive sometimes. I never hear you ask questions. I never hear you contribute anything. You don't even laugh at my jokes. So come on.
Have you ever thought maybe they're not that funny?
Yeah. You've been in agreement with my wife there because she has the same viewpoint as you. On the other hand, my mum used to laugh at my jokes even before I got to the punchline. So I can't really help it if you've got no sense of humour or taste or anything. I am so lucky I'm in charge of editing because all these insults, I cut them out so no one will ever know that it happened. So that is something good. Who knows, maybe one day I'll be able to be in charge of Facebook and make sure that people who say things I don't like, I can cut them out as well. That'll be cool. Yeah. So I'd go to those videos with movie stars who've been doctors who go and tell me what I should do with my life and say, nah, don't want to hear from you. Delete that video. That would be kind of cool. Oh, wait a minute, isn't that fascism when you do that? Darn it. All the good stuff, you know? Who was that quote? I think it was Mae West who said, how come all the fun things are illegal, immoral, or fattening? I just don't know what... Yeah. They're taking all the fun out of life. I mean, I used to be able to throw things at students. And that's not allowed anymore. So, I mean, where's the fun in the job? I mean, if I can't insult Jocelyn at least now and again, I'm going to get really bored.
You can throw math questions at us.
Yeah, but I do that all the time. That doesn't count. Jocelyn, you don't mind me picking on you, do you? Evidently she's left. Maybe she did mind. I apologise if I did. Are you still here, Jocelyn? I've lost her.
I have to keep going to my computer.
Why, do you watch it like across the room and you have to run over and hit the space bar, or what you do?
I'll pay attention to Zelda.
Okay, I'm just picking on you because I can. Okay, everybody, good morning. I think, whoa, that was weird. We're going to spend just a little bit more time on, oh God, I'm so easily distracted, on average values of functions, and then we'll move on to the last section, which is called work, and that's quite a big section. So let's start off with a straightforward question. If halfway through my sentence I'm pausing all the time, it's because people keep on appearing and I have to hit my button to make them join, and I am not good at multitasking. Okay, so imagine that we had a function x squared plus 4, and we wanted to find its average value from 1 to 3. So this is like a bog standard, nothing too weird going on. And the formula for getting the average value of a function is 1 over b minus a, the integral from a to b of that function. So 3 take away 1, the integral from 1 to 3, in this case it's x squared plus 4. So that's a half. Power rule, 1/3 x cubed plus 4x, evaluated at 1 and at 3. Here's the dangerous part where I try and do things in my head. That gets you 9, that gets you 12, so that's 21. And that let's cheat, make that 0. That way I can just have
It's gonna
take
be
away 0.
1/3, right?
Question?
It's gonna be 1/3 instead, because
Yeah, thank you for catching that. But at least that's better, because I get a nice number. I just wanted the nice number out of that. So if you can visualize what we're doing here is that x squared plus 4 looks something like this. And we're starting at 0, and we're finishing at 3. And we're saying if you look at the function from there to there, and what happens at 3? 3 is what height? 13. Starts at 4, climbs up to 13, and the average value of that function is about here, roughly. It's about 7. That seems reasonable. You know, somewhere between 4 and 13. 7 seems good. You're going to get some questions towards the end that then ask you to do one more thing. What they ask you to do is to find a number called C, because there's a theory that says that's at least one number C in the range 0 to 3 that has the property that the value of the function at C is the same number as the average. So can you imagine my picture here? That guy there would be the C, because you see the value of the function at C is 7. Does that make sense, that if you start here and you finish there, you have to pass through all the points? And so there's at least one place where it happens. So how do we solve this issue then? Well, if you think of this as being solving f of x equals 7, then that's really what you're doing. So we're trying to solve when is this function equals 7. Subtract 4 from both sides. Now, technically speaking, there are 2 answers that might work. And sometimes there are 2 answers, right? Sometimes the curve goes up and back down, so there are 2 places. But in this particular case, only one of these 2 is actually a usable solution. Would you agree? And the key is that we're only going to be looking from 0 to 3. So can you see that that one gets killed off? Now, in this particular question, it was possible for me to find the exact value for C. Basically, that's the guy they call C, right? So it was possible in this case to get the exact value. In some questions, it's not going to be possible. The function f of x is so ugly that when you set it equal to 7, you can't solve it algebraically, right? And so you'll know those situations because the question will say, find C to 2 decimal places, right? It'll phrase it in that format. So how do you go about solving a question when it's not algebraically possible, right? So I'm going to use the same question, and basically you let your calculator do it for you. So the function I had was x squared plus 4. So we're just going to pretend that this one wasn't possible. You go to your put in the average value, which is 7. You then go to your window and you choose 0 to 3. So I'll show you what I did. The original function, x squared plus 4, or whatever it really is. The second part is whatever the average value is. So if it's 22 or minus 40 or whatever it is, that's what you put there. You choose your window from 0 to 3. That way you're only going to look at the numbers at work. You don't want to see other possible solutions that aren't usable. And then you finish with a zoom 0, and that'll just show you what's going on. Now you can see that guy there is the one we're trying to find, right? So if you do second calc, does anybody remember which one of those choices is going to get me the place where the line and the curve meet?
Intersect.
Yeah, number 5, intersect. And it says, if you can read that, it's quite small, but it says first curve. So if I move this little cursor, you see it will drive my car. You see it's on the first curve. So just press enter. And then it automatically jumps to the second one. If I move my little cursor, you can maybe see it better. You just say enter. And technically, since there's only one answer, I should be able to do it. But if you just move a little bit closer to give it an easier time, and that's what guess is about, you go boom. And the answer is 1.73 and change. So you would just write down x equals 1.73, or actually write c equals 1.73. And we call with that process that you can also not just find the average value of a function, but you can, in some of the later questions, be asked to find points on the graph that exactly have that value. So I think that went pretty smooth. Nobody seemed to have any issues. Are we good? Right. Just give me a few seconds more. I want to, because God, the computer's been really awkward today. Right, I'm now going to switch over to the homework screen, and we'll maybe look at some, and if you want, if you find something a little bit weird, we can even do it. Okay, so here is homework, average value of a function. Let's zoom to about here. Okay. Can't remember which ones we've done, so I can talk through some of these. If you're going to do question 7, it's just an average value, right? There isn't that second bit yet. What method will you use to integrate e to the sine t cosine t?
U sub.
And the u sub will be?
Sine of t.
Correct. In question 8, what technique are you going to use here?
U sub.
And who's the u sub this time?
X cubed plus 30.
Right. Are we getting, hopefully, are we getting better at recognizing u sub questions? And what the u sub should be to make it work? What would, well, I can't really call it a u sub. I think I did this at least one of the two Calc 2 classes. That's why it's difficult for me to remember what ones we've covered. Did we do the log u over u guy?
No.
No, okay. Then that means I did do it with the other class, because I know I did it with one. I can't call it a u sub, so I'm going to call it a w sub. Right? You have to use a different letter. What would the w sub be? Because that's the method you're going to have to use here. And it's a sneaky one, isn't it?
Ln u.
Correct. I'm going to do that one, I think. I think it's a nice awkward one to do. So we're just being asked to find the average value. And I'm thinking this is a good example of why variables are just placeholders. mathematically speaking, isn't that the same information? You agree this and this are identical as far as math is concerned. So anyway, I sticking to this guy, I'm going to do a U sub. Because I can't do a U sub because that variable is called U. I will differentiate with respect to the variable. When I do my cross multiply, I get kind of lucky. We get that. So the integral of log U over U from 1 to 6 with 6 take away 1 is 5 to U becomes 1/5 W over U dW. The U's cancel. 1/5 integral of W. Oops, integral of W. 1/5 W. Too much in one go. Add 1 to the power. Divide by the new power. We get that. That gets me this guy. This guy now becomes log U. I can then plug in U equals 1 and U equals 6. So the average value of this function is 1/10. Plug in 6, you get the natural log of 6 squared. Take away, plug in 1, you get the natural log of 1 squared. Okay, let's see if we can make this a little prettier. What number is the natural log of 1?
Zero.
Right, so that whole thing disappears, and you are left with 1/10, the natural log of 6 squared. Not very pretty, but that is the answer. I do not like this pen. Are we okay with that question now?
Yes.
Okay, so let's now return back to the homework and see what else is still to come. Well, the next question. 8 sine x take away 4 sine 2x, and we are going to find its average value. Now, in that question there, aren't you going to have to integrate 8 sine x, take away 4 sine 2x? Okay. So let's look at that one. So take me a few moments to write it down, then we'll switch back. Well, the average value of this function is going to be 1 over pi take away 0. The integral from 0 to pi of 8 sine x take away 4 lots of the sine of 2x dx. The reason why I chose this question is, well, a couple of reasons. Major one is its trig. And the second reason is that it has find the missing C thing that we talked about earlier, right? So let's see where this one goes. Antiderivative of 8 sine x, what is that equal to?
-8 cosine of x.
Okay, so we didn't get cut out with that. Now, sine of 2x, or 4 sine 2x, if you want to worry about the 4, that has an antiderivative. How would we find the antiderivative of 4 sine 2x, or -4 sine 2x?
U sub.
U sub. Can you just trust me on this one for speed purposes, that the U sub would be 2x if you wanted to do it, and you go through the process, it basically just gets you an extra half, so you will end up with positive 2 the cosine of 2x. Can you just trust me on that and go and check it yourself later? Why did it turn positive? You should be able to figure that out.
Because the antiderivative sine is negative cosine. But,
Okay, so exactly. And can you just trust me that the 2 kills off part of that, and that's why it's 2. Right, so you are going to get 1 over pi, -8 the cosine of pi, plus 2 times the cosine of 2 pi, minus -8 cosine of 0 plus 2 cosines of 2 lots of 0, still 0. Oh, that's very messy. Okay, what is the value for the cosine of pi? Just the cosine of pi.
is it -1?
Right, so those two make that positive. This is -1, sorry, this is 1, so that gets 2, so that's the first bit. Take away, and this is 1, but that's negative, right? So I guess that's -8, and this is 1, so that's +2. So I get 10 take away 6, but take away is add. So I get add 6, so I hope I counted this right. I get 16 over pi. And that's part A done. Find the average value of the function. It's 16 over pi. Now, this question says find 2 values of C. They call it the small value of C and the big value of C, but that's fine. So I know there are going to probably be 2 answers. So I go into my calculator, and I'll just put this over the top of the writing right now. First thing I'm going to do is type in 8 sine x, subtract 4 sine 2x. And then I will type in 16 over pi, which is the average value. I'll then go to my window, and I'll make sure my window is only from 0 to pi. And then I'll do zoom fit so I can see it. And evidently there will be a horizontal line and a curve. There's the curve. Better curve round, come on, curve, there you go. And there's my straight line. And yep, just like they promised, you can see it's 2 different places. So I need to find this guy, and I need to find this guy. So you go second calc, you do choice number 5, intersection. And I'm going for this one here. So first curve, enter, second curve, enter, guess, enter. And the answer I get is 1.24. And that's a small one, right? Yeah, it's a smaller value. So I now go second calc, number 5 again, only this time I'm going to move my cursor over to the one on the right hand side, the big value, and we're going to find when is the average value meets up with the curve. So first curve, second curve, guess, and the second answer is at 2.81. So that's going to be the answer to the smaller value. This is going to be the answer to the larger value. Are we cool with that? Does that make sense?
I might have like entered something in wrong, but I got like different numbers.
Okay. Make sure your mode is in radians.
It's in radians.
Okay. Make sure that it's 8 sine x, take away 4 sine 2x. That's the next place.
Mm-hmm.
Definitely sure it's easy to miss them. Definitely good.
Yeah.
16 over pi is the other one.
Mm-hmm.
Then there's nothing else to go wrong.
I don't know.
I just do it again and see if it comes out. You know, sometimes weird things happen that you can't figure out why, but they just happen.
Okay.
Okay. That means you've got it all set up, right? So it will give you the right answer. I guess I could have done something wrong. Did anybody get the numbers I got when I was doing it? Right. We just have to leave that one. I'm assuming I did it right. You can certainly double check and tell me another day if I don't. Okay, I'm going to return now for one last visit to what the homework looks like. And here we go. Now, that's the one we just finished doing a minute ago. Question 12. Here is the function that you're going to find the average value from. The interval is from 0 to b, and the average value is equal to 3. And you are trying to find out who the number b is. Interesting question. A nice little puzzle. You're going to integrate this fella. It's going to be 1 over b. You're going to get an answer with b's in it, and then you're going to set it equal to 3, and there will be 2 values. That's a cool question. I don't want to give that away. That's a cool. I like puzzles. Right, this one is just ugly. You are going to find the average value of this question from 9 a.m. to 9 p.m. Right, essentially, from 9 o'clock till 21. That'll be the numbers. 9 a.m. is 9 hours and 9 p.m. is 21 hours. And here's a tutorial version of the same question. This question here just makes it sound like it's not what we're doing, but this is your f of x. And you're being asked to find the average value from 0 to 5. That's just what it means. So f of x is this ugly fraction, and you're going to find the average value from 0 to 5. That's pretty much. Now, you are going to have to do 8 over the square root of x plus 4. Like, imagine the integral, 8 on the top, the square root of x plus 4 on the bottom. What methods are you going to use to find that antiderivative?
U sub
And the u sub is going to be,
x plus 4.
and off you go, and it works. And there's a pretty standard function. Is it okay for the average value of a function to be 0?
Yes.
And it's okay to be negative. So don't be surprised if something like that happens in 17. And here's a much more standard question, right? Just find the average value. If I was doing question 18, how should I rewrite the cube root of x to make it doable?
To a power.
Right, that would do it. Now, 19 is a u sub, theta over 3. But when you do that u sub, you're going to have to integrate, after that, sine squared u. What is the antiderivative of sine squared u?
Secant squared u would be tan.
Right, so you end up with a tan and some numbers. Do you recognise question 20 is back to being a standard average value question? It's just a really, well, that two's quite strangely big. Right, in this question here, do you see that you're going to have to do a U sub? And the U sub is going to be what? T squared or negative T squared probably. Okay, then that is the end of that, I hope. And we are now going to be looking at the last section that we need to worry about for the test. So, what is section 6.4 called? Well, it's got a nice short name. And it's called work. So if some of you have done physics, I'm sure you will have done questions involving the work needed to push a block up a hill or to lift a bucket 12 feet off the ground and things like that. Does that sound familiar to some of you? Work done. Right. Now the general formula is that work is made up of a simple formula: force times distance. F is the force used, and D is the distance. Now, the kinds of questions we're going to be dealing with are where you're working against gravity. So you've got something on the ground, essentially, and you lift it off the ground. That's a very simplistic version of what's going to happen. So we'll start off with very straightforward questions. Suppose I had a 5 pound weight, and that's the ground, and I move it to here, and that's the distance 4 feet. How much work have I done in doing that? Well, the weight is 5 pounds, so that's basically the force, and you multiply it by the distance, 4, and you get the answer 20. And the units here are feet times pounds, so they're called foot pounds. Similar looking story. 5 kilograms, and you lift it up a little bit. Let's keep the numbers the same, although the units are not. I hope so. And you do it 4 meters. The distance is definitely 4. Not changing that. And the force does have a 5 in it, because the thing is 5 kilograms. You also have something else, don't you? When you do metric, what are you fighting against when you lift something off the ground? Well, you're fighting against gravity. And doesn't gravity roughly is 9.8 or 9.81? I think it's 9.812 if you keep going accurate on it. So let me check what they use. If they don't tell me, I'll just pretend I know. Okay. Shall we call it 9.8?
It's 9.8.
Okay. 9.8, stick the whole package together. And this should feel like a very intro to physics class right now. And the answer I get is 196. And force is in newtons and distance was in meters. So we call it 196 newtons. I believe that's the same thing as 196 joules. Does that make sense for those people who've done this? Right, for those who've not done it, here is your rules of the game. If the thing is in pounds and you move it in feet, just multiply them together and that's your answer. If the thing is in kilograms and meters, you need the extra 9.8 as a conversion to the units that they use in the metric system.
Professor,
Yes.
I'm not sure. In the second problem, I'm not sure if the units are correct.
Okay, I could be wrong.
Because the 9.8 that has units as well.
I can't argue with that because I'm not a physics person. Because someone who does know a little bit more of physics, I'm 99% sure that the final units are Newton meters, and that's called joules.
I thought
what units do you think? Sorry, what units do you think it's in? And then we'll do a little unit analysis.
When I learned it, I learned Newton meters were the units for torque, and the unit for work was, I thought, newtons. I could be wrong though.
Well, I could be wrong. Well, we just agree to disagree on the units, but be happy with the 196-bit. And I'm looking at a question here, and the question here tells me they're called joules. So as long as we call it joules, we'll be fine, right?
Okay, thanks.
It may also be that it is Newton meters. It may also be that it's not Newton meters. That part I really don't feel comfortable about. I am going to mute. I was getting some doors earlier on, which was quite distracting to me. Here we go. Are we cool with this?
So for anything that's in the metric system, we have to have the 9.8 in there. Is that
pretty
right?
much, yeah. So if you're not a physics person, you're doing it because I tell you, right? And if it's feet and pounds, you don't need it. And if it's metric, you do. That's pretty much just the rule of the game. Now, it's kind of trick question, but we've got to do it because they're going to do it to you. Suppose I lifted this 5 pound weight 4 feet off the ground, and it took me 20 foot-pounds, right? 20 units of work. If I did it in 5 seconds, right? If I lifted that weight up and it took me 5 seconds to do it, how much work have I done? It's a trick question. How much work have I done in lifting that weight?
Would it be like 4 pounds per second or 3
No.
The
No,
same.
that's why it's a trick question.
Is it the same?
It's the same. Work doesn't care how long it takes you to do it. So there's a couple of questions at the beginning that say, okay, you do this in 5 seconds and then you do this in 10 seconds. And the answer in both cases is it's still the same amount of work. Right? I work slowly or I work quickly, but I still do the same amount of work. And so work doesn't care about time. So there's only a couple of questions where they chuck this, oh, we did it in 5 seconds and then we did it in 10. How much work did we do? And the answer is you did 20 foot-pounds in both cases, and it's still 196 if we did it in joules. Are we cool with that? Now, that's the intro to what you might have done in a physics or kinematics course. Or I'm never sure, where do you do this stuff? Those who've done this, what class was it in?
Physics.
I took I took Introduction to Physics last quarter, and we learned about work and force.
Okay, so it's from physics. There's a kinematics class. Is kinematics when things are moving then? Like it's velocities and accelerations and stuff like that? Is that what that class is about? Right, okay. Doesn't really change things, I'm just curious. Okay, so let's move beyond the kind of straightforward one and say, right now, these questions, force has been a fixed number. Right, it was 5 pounds or it was 5 kilograms times 9.8, it was a fixed number. But what happens when force varies with position? how do we calculate the work done now? So this is called the force function. And the work done in moving an object with this force function from position x equals A to position x equals B is just that. That is remarkably simple, isn't it? That all you need to do is find out at every given position x on that object being moved from where it is to where it's going to end up. If you can tell me what the force is at every position x, right, then integrating that function, that force function, will be the work that you'll have done. So imagine I have an object and the force function is x squared, and I'm moving it from 0 to 4. Then the work done will simply just be the integral from 0 to 4 x squared dx. So in this case, 1/3 x cubed, evaluated at 0 and at 4, which is 1/3 4 cubed, take away nothing, which is 64 thirds. And I guess I need units here. So, well, actually, I'm just looking at the questions. You don't need to worry about the units because when they do the box, they write the units next to it. So all you need to do is fill in the numbers. So you don't even need to worry about what the right units are. They're telling you what they are. So that kind of simplifies the issue that we had with Matthew, saying, well, what are the units called? Because I don't think they're called Newton meters. And we don't need to really worry what they're called because the question's going to tell you the units after the box, which makes life easy. So as long as I know what the force function is, can't I basically find the work done? Yeah. Next question is going to look something like this. I'll do my own version. I have to put in some numbers here, so I'll make that 5, I'll make that 0, I'll make this 10, I'll make this 20, and I'll make this 2. There we go. This represents our force function. So I guess you're moving this object, and as you're moving it along, right, as x changes value, as you're moving it along, it's requiring more and more force. And then you hit this point where the same force will move it, and then it gets a little bit easier towards the end. Now, if you want to calculate the work done, won't it be the integral from 0 to 25 of the force function? Well, this guy is not going to be done by the power rule or any other algebraic method. Aren't we basically just going to find the area of the whole shape? Now, this fella is a triangle, and this triangle is 10 by 5, and half of 10 by 5 is 25. Are you comfortable with me doing that in my head? Right. Wouldn't this middle rectangle be 10 units by 5? So that would get me 50. So I guess I should write these down as I find them. And this shape here, I guess I could probably break it into 2 little shapes. That's a 5 by 2, which is 10. And this little triangle is a 5 by 3, and half of a 5 by 3 is 7.5. Is that right? Yes. And 7.5 is 15 halves. So you add that whole lot together, 60. 75, 82 and a half. To keep mathematicians happy, 162, 165 hearts. Are you comfortable with that type of question where if you're given a graph and you want to find the work done, you basically just find the area of what's under the graph? It'll be rectangles and triangles. Let's double check it is. So that's good. Are there any questions so far, or are we good? Right. The next fella I'm going to do for you, and it's really just an intro, and tomorrow we'll continue at this. Has anybody heard the Hooke's law? And it deals with springs. Anybody here did Hooke's law? Okay. Then it's brand new for everybody. Imagine we've got a spring. And if you leave a spring alone, it's got a certain distance, right? A certain length. And this is what's called its natural position. Now, if you take a spring and you stretch it, right? You pull it. There's a force required to move it, right? Great. And the force function, according to Hooke, right, the force required to move a spring beyond its natural position, so the force function called f of x, is a simple formula. It's k times x, where x is the distance beyond its natural position. So can you imagine I took this spring and I stretched it to there. This distance here is its natural position. The extra bit is what x is. So x is not the total length of the spring. Isn't x the extra bit you stretched it? So this here is its natural position number. And he discovered that it was equal to kx. This k is a constant. It's a fixed number. And once we know what that fixed number is, we can then calculate the work that would be required in stretching a spring any reasonable distance from its natural position. Do you know shock absorbers, or at least the spring part of a shock absorber, use this feature that can't springs absorb energy, right? Absorb bumps in the road. Right? And so basically we're calculating that thing. So let's have a story to show you how that would work. Let me pick one. A force of 20 pounds is required to stretch a spring .2 feet beyond its natural length. And then the question comes after that. How much work W is done in stretching it 6 inches beyond its natural length. So we're given a piece of information that it requires a force of 20 pounds to stretch a spring 2 feet beyond its natural length. How much work is done in stretching it 6 inches? It could say next time 3 feet, next time 9 inches beyond its natural length. So we know the force function is kx. We're told that the force was 20 pounds and we're told that x was 2. So basically that intro had one job, to allow us to get k. Right, so k times 2 is 20, right, 2 feet. K times 2 is 20. Does it not make in this story k10? So I now know my force function. Oops. There we go. I now know my force function. Now the question says, how much work is done in stretching at 6 inches? Well, the work is the integral, right, from 0, its natural position, to 6 inches, the force function, dx. I do not put 6 here. 6 inches is not going to be 6. Think units.
0.5?
Yeah. If you're going to do these questions, units are going to be your enemy. So here's the rules of the game. All distances are feet. All distances are meters. So if they tell you it's 6 inches, that's half a feet. If they tell you it's 18 inches, that's 1.5 feet. If they tell you it's 3 feet, it's 3. If they tell you it's 2 meters, it's 2. But if they tell you it's 42 centimeters, it's 0.42, because 42 centimeters is 0.42 meters. So the rules of this game are feet and meters, right? Everything is feet and meters, regardless of how they gave you in the story. Convert them to feet and meters. Right, this guy here becomes 5x squared. While I'm finishing this off, do you want to say hi? So we can get attendance done. And 0.25, and this is 1.25, I believe. And you're finished. Does this feel like a physics class today?
I was going to say, in my physics class I took last quarter, we actually learned about that formula, but we didn't call it Hooke's law.
So that poor guy Hooks did not get any credit. That's just not right.